During this segment, we will review properties of real numbers. Let's begin by talking about some symbols that we've not talked about before. Remember, this symbol means is equal to. This symbol means is not equal to. And then let's look at some other inequality symbols. You've seen them before. This symbol means is less than. And then this symbol means is less than or equal to. And then we have, of course, is greater than symbol. And then is greater than or equal to. Now let's use those symbols and let's write this as a mathematical statement. Here I have twice x plus 5 is the same as negative 14. Let's translate this to a mathematical statement. How do we translate twice x? Well, that would be 2 times x or 2x. So twice x is 2x plus 5, plus means addition, plus 5 is the same as. That's one of those phrases that does mean is equal to. So is the same as, that means equals, negative 14. And we've translated this sentence to an equation. Twice x plus 5 is the same as negative 14. Let's continue to use the symbols we just talked about. And let's suppose I have 7 4/10. And let's compare that with 7 40/100. I'd like to replace this or place a symbol between these two numbers that makes this a true statement. And I'll use less than, greater than, or is equal to. Which statement makes this, or which symbol makes this a true statement? Well, 7 4/10 is the same as 7 40/100. Since they are the same, I replace, or I place in that spot, the symbol is equal to, and now we do have a true statement. Let's try that one more time. We're going to use one of those 3 symbols. Let's suppose I have 7 11s and 9 11s. I'd like to place between the two numbers one of these 3 symbols so that we have a true statement. Well, how do these two compare? When the denominators are the same, you can compare the numerators. Because 7 is less than 9, 7 11s is less than 9 11s. So we use is less than, and I have 7 11s is less than 9 11s. That is now a true statement. Now let's talk about reciprocal, opposite, and how they relate to properties of real numbers. For example, I'd like to first see if we can't both discover what we call the additive identity. Now we call it the additive identity because we're looking for some number that when added to any real number gives us the result of the same real number. In other words, A, any real number, plus what number equals A once again? Well, we know A plus 0 equals A, so we call 0 the additive identity. Now let's do the same thing with multiplication. A times what real number is equal to A once again? Same thing except for multiplication. A times what real number is equal to A once again? Well, that number is 1. A times 1 we know is A. So we call 1 the multiplicative identity. Now we're used to the words reciprocal and we're used to the word opposite, but how do those relate to properties? Well, it's the following. Because A, any real number, plus its opposite gives us, remember 0, which we call the additive identity, we say that this opposite is also the additive inverse. So opposite and additive inverse are the same thing. It's also true that any real number times its reciprocal, and of course here this is as long as A is not equal to 0. a times 1 over a is equal to the multiplicative identity, right, which is 1. These are called reciprocals of each other, but since their product is the multiplication identity or the multiplicative identity, we say that these are not only reciprocals, but we say that these are multiplicative inverses. So just remember, reciprocal is the same as multiplicative inverse. Opposite is the same as additive inverse. Now keep those in mind and let's fill in this table, if you want to call it a table. Let's suppose I tell you some number has 8 as its opposite. What is the original number and what is that number's reciprocal? Well, if the opposite of some number is 8, the original number must be -8. The opposite of -8 is 8, correct? And then if this is the original number, what is the reciprocal of this original number? The reciprocal of -8 is 1 over -8, or -1/8. So there's my number, there's the opposite. Notice if you add these two, you get 0. Notice if you multiply these two, you get 1. And that's how that works. Let's try that again. Let me put 0 this time as my original number. Suppose 0 is my original number. What is the opposite of 0? The opposite of 0 is 0. Notice the sum of these two is 0. What is the reciprocal of the number 0? Well, actually, 0 has no reciprocal. There's no number such that when you multiply it by 0, you get a product of 1. So 0 has no reciprocal. And let's do that one more time with one more number. Let's suppose I tell you the reciprocal of some number is 8 over 7. What is the original number, and then what's the opposite of that number? If the reciprocal of some number is 8 over 7, what is the number itself? The number itself is 7 over 8. Notice this product is 1, so we know that they are reciprocals. And then what is the opposite of this number? The opposite of 7 over 8 is -7 over 8. This sum is 0. This product is 1. And that'll work every single time. Now let's talk about some other properties of real numbers. Here are the commutative properties. Remember, commutative properties have to do with order. So for addition, it is true that a plus b is equal to b plus a. For multiplication, it is true that a times b is equal to b times a. Notice the order has been changed. Associative properties, those have to do with grouping. The associative property for addition states that a plus b in parentheses plus c is equal to a plus in parentheses b plus c. And the associative property for multiplication states that a times b in parentheses times c is equal to a times in parentheses b times c. Notice each time regrouping has been done. And then finally the distributive property. Again, a, b, and c, they are real numbers, and it is true that a times in parentheses b plus c is equal to a times b plus a times c. So let's now use the commutative property for addition, and let's write an equivalent expression. Since we are using the commutative property, that has to do with order, so 7x plus y is equal to y plus 7x by the commutative property for addition. Notice I changed the order here. Let's do that again with another expression. Let's suppose I have 5 times, in parentheses, 7x. Let's use the associative property for multiplication, and let's write an equivalent expression. Now remember, 7x means 7 times x, and associative property means grouping. So this is equal to, I'm regrouping 5 times 7 in parentheses, and then times x if you'd like. As a matter of fact, we can now simplify this expression on the right. What is 5 times 7? That is 35 times x, and I can write that as 35x. But this is equal to this by the associative property for multiplication. Now let's look at the distributive property. Let's suppose I have 3 times x plus 5. Let's use the distributive property to perform this multiplication. Find the product. By the distributive property, the 3 distributes to each term within the set of parentheses, so that's 3 times x plus 3 times 5. Well, 3 times x is 3x plus 3 times 5 is 15. So by the distributive property, this equals 3x plus 15. Now let's practice writing algebraic expressions. Let's write an algebraic expression for the following. Write an expression or an algebraic expression for the amount of money in dollars in D dimes. Now it's very important for you to understand the difference between the number of dimes and the amount of money in dimes. For example, if I have 5 dimes, 5 dimes is the number of dimes I have. The amount of money I have is 50 cents or half of a dollar, but that's the amount of money compared to the number of dimes. Two different things. So here, D is the number of dimes. If we know how many dimes we have, the example I mentioned was 5 dimes, how do we calculate the amount of money we have in dimes? Well, we multiply the number of dimes we have times what a dime is worth, 10 cents or 10 hundredths or 1/100th of a dollar. So D is the number of dimes. The amount of money we have in dimes is, you can write it as 10 hundredths if you want. That is the money in dimes. And you can write it if you want, or 1/10 D. So this expression or this expression gives us the money in dimes. Keep that in mind when working with money. Let's now look at another example, a little bit different. Here, two numbers have a sum of 112. If one number is x, represent the other number as an expression in x. For example, if one number is, say, 100, the other number is 12 because they have a sum of 112. If one number is, say, 111, the other number is 1 because the sum is 112. Now, by the way, if you know what one number is, if one number is, say, 100, how do you calculate the other number? The other number is the rest of the 112. So the other number is always 112 minus this number. 112 minus 100 is 12. 112 minus 111 is 1. In general, if x is one number then and the sum is 112, the rest of the 112 is the other number, so it is the same as these. It is 112 minus x. And we have just represented the other number as an expression in x. Notice, if you add these two, you get 112. Add those two, you get 112. If you add these two, you get 112 also. So there's my expression. Let's now review how we simplify an expression, and remember we simplify an expression by combining any like terms. Don't forget that like terms have the same variables raised to the same powers. So let's simplify this expression by looking for like terms. Notice, of course, this is a constant and this is a constant, so I can certainly combine those two. Negative 9 plus 18 is 9. And then notice these two are like terms. So I have 4x minus 10x, that is 4 minus 10, which is negative 6, times x, so negative 6x. So I'll write that as minus 6x. So there I have simplified. I can go no further because these are now unlike terms. So simplified 9 minus 6x. Let's try that again. Let's look at another expression. And let's simplify that expression by combining any like terms. I have 3 times in parentheses xy minus 2, and then plus xy plus 15 minus x squared. Now I want to simplify this expression, so we will first use the distributive property to remove parentheses and multiply. So 3 times xy, or 1xy, is 3xy, minus 3 times 2 is 6, and then plus xy plus 15 minus x squared. Now that we've multiplied and parentheses are gone, let's look for any like terms. These two terms are like terms, and don't forget there's an understood 1. So this is 3xy plus 1xy, which is 4xy. And then these are constants. So I have negative 6 plus 15, and negative 6 plus 15 is 9. So that's plus 9. And then I have no other terms like this term, so I'll simply rewrite it, minus x squared. So 4xy plus 9 minus x squared. I can go no further. These are all unlike terms. By the way, you can rearrange the order of these terms. That's perfectly okay. If you have 9 plus 4xy minus x squared, that's perfectly okay. Remember, addition is commutative. So I'm not making a statement about the order of the terms here. I'm just saying this is simplified. Let's try that one more time. Let's simplify this expression. Now, to begin simplifying this expression, let's use the distributive property. So what is 1/2 times 10x? Well, 1/2 of 10, or 1/2 times 10, that is 5. So I have 5x minus 1/2 times 2, that's 2 over 2, or 1. Now let's be very, very careful here. It's minus, what is 1/6 of 60, or what is 1/6 times 60? It is 10. 60 over 6, which is 10. So I have 10x. And then here's where a common error is made. Negative times a negative, this must be plus or positive. And then what is 1/6 times 5? It's just 5/6. And then y. So go over my multiplication if you need to, but we've now multiplied, we've removed parentheses. Let's look for like terms. Those are like terms. 5x minus 10x, 5 minus 10 is negative 5x. That's my only constant, minus 1, and then plus 5, 6y. Again, in any order. You could have written this as 5, 6y minus 5x minus 1. It makes no difference the order here, but I can combine no more terms because they are unlike terms. All right, at this time, practice going over like and unlike terms and simplifying expressions. Let's now check on how you are with simplifying an expression by simplifying the following expression. And that is 9 minus 5 times parentheses x plus 2, close parentheses, minus 2x. Once you simplify, does it simplify to choice A, 2x plus 8, to choice B, negative 1 minus 7x, or to choice C, 19 minus 7x? The video will pause, take a moment, simplify, and then make your choice. Choice A is incorrect. Let's correctly simplify this expression. Now remember, we have subtraction, multiplication. We may not subtract before multiplication in order of operations. So do not subtract. What we need to do first is use the distributive property. So negative 5 times x, that's minus 5x, and then negative 5 times a positive 2, that's negative 10. I'll write minus 10 minus 2x. And then we look for any like terms. We have 9 minus 10, that's negative 1, and then negative 5x minus 2x, that's negative 7x. And if you notice, that is choice B, so B is the correct selection. Choice B is the correct choice. Let's make sure we all understand why. If I simplify that expression, we first use the distributive property, so that's 9, and then minus 5, or negative 5 times x, that's minus 5x, and then negative 5 times 2, that's minus 10, and then minus 2x. And then looking at like terms, 9 minus 10, that's negative 1, and negative 5x minus 2x, that is negative 7x. These are now unlike terms. I can go no further. The correct choice is choice B. Choice C is incorrect. Let's see why by going through and simplifying this expression. Now we do have subtraction and multiplication. Remember, we must multiply before we subtract. So let's use that distributive property. What is negative 5 times x? That is negative 5x. I'll write minus 5x. And then don't forget also negative 5 times positive 2, that's negative 10. I'll write minus 10. And then minus 2x. Then looking for like terms, 9 minus 10, that's negative 1. And then negative 5x minus 2x, that's negative 7x. I write minus 7x. These are unlike terms. I can go no further. If you notice, that is choice B. Choice B is the correct choice.